Okay, so let's get started. We're going to be taking a look at setting up and programming our injector data into our Link G5 and G4X. This particular tutorial is going to be learning how to take the data from a data sheet and bringing it in here to our programming. Our last training module, we actually explored the fundamentals of what injector data actually represents. So at this point, you should understand what the flow here represents, the dead time latency, short pulse width, and minimum effective pulse width. All of this information is needed so we can enter it in here when we're working in the modeled mode, which is our air mass strategy. If we're dealing with a traditional fuel equation mode, we still need to enter in the injector dead time. The short pulse width isn't as important, but we can enter that in, and the minimum effective pulse width also needs to be entered in the traditional mode. What we don't have to worry about is the injector flow right here. We actually set up a fuel trim value and use our fuel table here as a percentage scaling against that main fuel trim value in order to get things worked out in that traditional mode. We'll get into what all that represents future training modules. Either way, we need to enter in the injector data, and we should know what it all represents. Again, because the last tutorial, we really dug into those fundamentals. Let's jump in here and take a look at how we're going to be setting up injector data for the calibration file I'm working with here for my Honda K-Series application. I'm going to be showing you how to take injector data from FIC, which is supplied in an Excel spreadsheet format, and bring it in here to our calibration file. I am working in the modeled mode, so I do need to make sure that I'm hitting all 4 points that we covered in that last training module: minimum effective pulse width, dead time, short pulse width, injector flow. We're going to be touching on the optional 3-dimensional table that we can set up for our latency or dead time. That's going to be something we cover a little bit later. I'll also show you in this training module how to import calibration data for injector dynamics injectors, so you don't have to actually go into their data sheet and transfer it over by hand. I've actually supplied all of the ID data within just a plug and play format for our Link. Really nice time-saving feature. Let's jump in here and take a look at setting up our injector data. It's very straightforward, but again, I wanted to do a training module on this specific topic because if you're new to tuning, you want to go through and set up everything correctly in your base file, and a lot of people want to know how to set up a base file correctly, and injector data is definitely one of those very critical, very important things that we get right. So let's go through those details. Okay, what I'm going to do is move from our basics page right here that has all the programming tables and information that we need for the injector data. Let's go to the actual data sheet. Now, in order to get the Excel spreadsheet from FIC for the injectors that we're using, which is their saturated 1000 cc injectors, I went to FIC's website, which we can find right here, fuelinjectorclinic.com. I went to the ECU data, and then I went down here to the Link 64 data. This is data specific for our Link system. We can choose through then the further drop down to select which injectors that we have. I chose the 1000 cc, and I downloaded the Excel spreadsheet to my desktop for my computer. So I'm able to actually view that, which I have open right here. Now, FIC, DW, and Injector Dynamics are all reputable injector manufacturers. They all supply their data within an Excel spreadsheet as we find here. This is what you want to be working with when you're transferring your data. Other injector manufacturers likely cannot provide the information in an Excel spreadsheet, which isn't necessarily the end of the earth. Usually the injector data is incorrect. Even with ID, FIC, and DW injectors, the data is a starting point. So we still might need to adjust and tweak the data a little bit, and I'll explain how to do that in a future training module. But for right now, let's just get the data into our calibration file. What we're going to find here is when we open up the Excel spreadsheet, we actually find that we have 2 tabs down here at the bottom: 3-bar data, 4-bar data. This is going to be basing the injector information that we have to enter in on the base fuel pressure that we have in our fuel system. So 3-bar is going to be the equivalent of 300 kPa or 43.5 psi of base fuel pressure. 4-bar will be then the equivalent of 400 kPa or 58 psi of base fuel pressure. You'll either typically have your base fuel pressure at 3-bar or 4-bar. So it's going to be one or the other. In my case, my injector my base pressure and my injector information here is going to all be based on the 3-bar data. So that's my base pressure in my system. Now, a good way to test your base pressure to see what it's actually at is to go into your outputs here. Let's just jump in real quick. With your key on, engine off, if you go to outputs and you go to your fuel pump control, you can do a test and actually prime your fuel pump when your engine's not running and see what your fuel pressure builds to. If you have a fuel pressure sensor fitted to your link, which is something I highly recommend that you do for both fueling calculations, as we're going to talk about just a little bit here for the injector data, improves that the injector data tracking to your fuel pressure. As fuel pressure changes, it changes things within your injector flow and as well as your injector dead time. But it also allows you to see if there's a fuel pressure problem. Most cars have some type of a fuel pressure problem, so a fuel pressure sensor, in my opinion, is an extremely important and valuable sensor. It allows you to check your base pressure. So if you go here and do your test and you watch what the fuel pressure goes to, we can actually see that channel right here. If we go to fuel and we go down here, we can actually see what the differential fuel pressure shows. Fuel pressure and differential should technically match, key on, engine off. The differential pressure is your base pressure. So whatever this is showing is what your actual fuel pressure is at, and that's what you want to go and reference from the data sheet here. If your fuel pressure isn't either at 300 or 400 kPa, then adjust your actual fuel pressure regulator in order to get your base pressure there.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.